4.2. Continuing on with what the French toast, the solutions are what's going to get us a little crazy. Now, solutions does mean my x-intercepts, which is why I don't know what the elaboration is on all this extra stuff. But let's look at the following example. Question 1. Consider the function f of x equals x minus 5 to the power 2. It's this quadratic function right here. Determine the solutions and solve algebraically and label the solution on the graph. If I solve this, you take the square root, you take the square root, so you're left with 0 equals x minus 5 plus 5 on both sides. You get x equals 5, which is correct. It's right here. That's my 0, that's my solution. So why did we do 4.1? Like I said, can't wait to get more understanding on what is exactly the bigger picture, but that's going to be for definitely next year. Interpret the solution in terms of the axis of symmetry and the parabola y equals the same exact thing. Axis of symmetry is cutting through my vertex. Don't forget that the bottom or the top part of my quadratic function is called my vertex. Also my minimum or maximum value. Okay, so that's my axis of symmetry, still going through x at 5. Describe the zeros. Again, this is an x-intercept. Solution, zeros, x-intercept, and roots are all the same type of ordeal. Of course, we don't want to get you all scared, so don't get too scared. It's just asking about the x-intercept. Describe the zeros. There's only one. 1, 0, x equals 5. Okay. Number 2. Not going to really go a whole bunch of detail into number 2, only because if you graphed it in Desmos, it's basically the same graph. Let's focus on the graph. But instead of it being like this, it's just a little bit skinnier. I'm going to do a dash, but it's touching the same point. It's kind of like this. Definitely do it on Desmos on your own. I'm just not doing it right now to save some time. But it looks like this, but it's still hitting at 5. Write the terms, write g of x in terms of f of x described in the transformation. I'm taking this part out. I'm going to write g of x. Sorry, let me make sure it looks nice. G of x equals that 2 is what's making it skinnier, thinner. 2 times my regular function f of x. If you go back to the top, you'll see that f of x is this part of the function. And if we go back to the bottom, the only thing that happened with g of x is now we're multiplying it by 2. So that's why we're doing 2 times the regular function f of x. We already sketched the graph. How have the zeros changed? They have not. If we did it algebraically, you would see that the axis of symmetry, the roots, all the stuff is basically the same thing. All that changed was how quick the function is changing vertically. Okay, very interesting. Not gonna do Parker. Parker can go hang out over there. Make a conjecture, not gonna, oh, okay, we gotta look at that. How does changing the A value affect the solutions? So this is my vertex form. F of x equals A parentheses x minus h to the power 2 plus k. Vertex form's telling me a lot of stuff. Obviously right now they're talking about A. A is what's making the graph go wider, or I forget the other word. It's wider or compressed like this, compressed horizontally. So it's either making it like this or it's making it like super skinny like this. Okay. H and K is what's making it go left and right, up and down. Again, this was transformations from topic 1. I don't want to go into an intense detail of it because we want to save some time. Okay? Number 5 is pretty intense. Definitely give yourself a little bit of chance. I'm going to do letter A. I definitely recommend I'll do letter C and I'll do letter E to make our life a little bit kind of easy, you could say. You're gonna do D, B, and F. Okay? Starting it out, this is what we've already done. Take the square root, take the square root. What's left over? X minus 4. There is no perfect square root of 2. Leave it like that with plus or minus. Plus 4, plus 4. Got X equals that 4 plus or minus the square root of 2. This is what they want. Take a quick mental image. Doing letter C. We have this A value that's in the way. Before we start doing the square root, we got to divide both sides by that A value, -2. -2. These cancel. Now we're going to look at this guy right here. Not going to do everything so fast. Let's divide that. Sir, how do you divide that? Negative turns positive. But of course, if we need our calculator, that's no problem at all. If you like it like that, that looks cool. Still gives me 9. If you want to do alpha, y equals, enter. We can also do it this way. It'll still give me the same answer. 9 as well, okay? Now I could take care of business. Square root. These cancel, so now I only have x minus 1 equals. This is actually a perfect square. Gonna check it out. Square root of 9. That gives me 3. Don't forget, it's plus or minus 3. Plus 1. X equals 1 plus or minus 3. Of course, we can solve this easier because we can separate them. We can't really do this because the square root of 2 does not give me a nice number. Letter E. Letter E is a little bit weird. Very weird indeed. Make sure you can kind of follow because it's the exact same thing as F. So I need to get rid of that -1/2. Now, I know a lot of my kiddos are going to say, well, sir, that's 0.5. Can I just divide by -0.5? And I will say, yes, I definitely encourage that. But because you're about to do 2/3, 2/3 is not a nice number. So this is what we're going to do. We're going to multiply both sides by the negative reciprocal. So, hold on. Is it negative reciprocal? Sorry, not the negative reciprocal, the positive reciprocal, meaning just let's multiply by reciprocals. Okay, which means I'm going to multiply this side by 2/1, which means I have to multiply this side by 2/1 as well. Multiplying 2/1 to this side, it is -1/2, sorry. -2/1, -2/1. Sorry about that, I'm keeping this negative sign. Multiplying this side by 2/1, it crosses out my fraction, leaving x plus 8 squared. Negative times negative, 32 times 2, that gives me positive 64. I don't need the over 1 because 64 divided by 1 just gives me 64. That was a little hardcore. Hopefully my teachers in the building can help make sure the kiddos know reciprocals. We're keeping the same sign. We're just flipping the numerator and denominator. We're flipping that fraction. Now I could do the good stuff. Square root. What's left over? Oops, sorry. X plus 8 equals 64 is a nice square root. Square root of 64 gives me 8. Plus or minus. Now I get to subtract. X equals -8 plus or minus 8. And we could solve this because it gives us regular numbers. Okay? Definitely internalize, ask questions in the room. A lot of intense stuff. Again, this stuff is just getting us prepared for the quadratic formula, which should be happening pretty soon. All right, next video.